Hello everyone, this is Dr. Krastowski here with your narrated video lecture on Chapter 7 on memory. So in this chapter, we're going to start by defining what memory is and talking about three processes of memory: encoding, storage, and retrieval. And then we're going to talk about the information processing model of memory that breaks memory up into stages. And we're going to cover each of those stages individually: sensory memory, short-term and working memory, and long-term memory. And as we learn about each of those stages, it is important that you're able to know how much information can be stored in that stage of memory and how long will it be there. Then we're going to get at different reasons why we forget, and we're going to learn some things about memory that might surprise you, things that show how malleable or changeable memory is. And in the end, we're going to cover some of the biology in memory. Some of it you will know already from Chapter 3 on biology and behavior. We're going to look at different types of amnesia and what exactly is the biological basis for memory. So before we begin, I want you to sort of reflect on how you currently think of your own memory. Memory is one of those abstract concepts that we can't directly see and weigh on a scale to know how much of it you have, yet it is something that we still know that we have and we somehow think about it. So oftentimes we use some analogies. So when you think about your own memory, do you think of it more like a video camera where you're recording everything that happens to you, the memory on a computer, the memory that you might record in a diary? Think to yourself how you currently think of memory. Now, once we get into this chapter, we're going to see that none of these things come close. With a video camera, you can hit the rewind button and see the instant replay and know exactly what happened. That's not how our human memory works. Human memory is also affected by emotion. So some people might be drawn to the journal analogy, because when you keep a journal, not only are you recording the events of your life, but typically the feelings that go with it. So there's some helpfulness to that analogy as well, but that doesn't quite work as well. We often use computer models, but again, the human memory system is not quite like a computer. With a computer, however I store a document or a file away, as long as my computer doesn't get a virus or corrupted, it should be exactly the same when I retrieve it. With human memory, we're going to see every time you retrieve a memory, it could be a little different because now you know something different, you feel something different. So you are reconstructing your memories every time you bring them back to mind. So let's start with the first objective, which is to define what memory is. We just finished the learning chapter last, so one way to think of memory is to think of it as learning that has persisted over time. It's the kind of information that you have stored away and that you can retrieve it at some point in the future. Now we're going to talk about the three different processes in memory. And it's important to know these three processes because when we then get to the parts that deal with what kind of things help or hurt our memory, we're going to see that things could go right or wrong at any of those three processes. So the three processes in memory are encoding, storage, and retrieval. So encoding, think of that as learning, getting things into your memory. Storage is once you have learned it, once you've encoded it, then keeping it there until you need it, retaining that knowledge, and then retrieval is bringing it back out at some point in the future. So I encourage you to pause me now. You can use this link or access it through the module in Canvas, where you will be taken through a video that will sort of give you a nice summary of everything to come in this chapter. So look at the video and take notes on the video about the information processing model. So we're going to cover this information processing model that breaks memory up into three components. Sensory memory, which refers to typically how things get into our memory through our senses, input from our eyes, our ears, all of our senses, but with humans, most of what we learn comes from vision and hearing, so we're probably going to focus a little more on that. And then the next is short-term or working memory. When we cover that stage of memory individually, we're going to differentiate why that one stage sometimes is referred to in two different ways. But anytime we're paying attention to something and holding it in our awareness and maybe thinking about it or doing something to intentionally try to learn it, so even concentrating on the words I'm seeing, looking at the things that you're seeing on the screen and holding it in your awareness and thinking about it, that is the next stage, which is short-term or working memory. And then from there, information can go into long-term memory where it could be for later retrieval. And then anytime we retrieve something, we're bringing it back into our immediate awareness. We're bringing it back into that second stage of memory. And then once we're done thinking about it, once we're done processing it, we put it back or re-encode it into long-term memory. And every time we do that, we might put that memory away a little differently because maybe now we've thought differently about it. We've learned something more about it. So in memory, and we've brought up this topic going way back to the first chapter on how psychology can help your own learning even in this course. So talking about the levels of processing. The deeper you process something, the more you think about it, the more you connect what you are trying to commit to memory with things that are already in your memory, things you already know, the better you're going to learn and remember that information. There's some famous studies that demonstrated under what circumstances, what kind of processing will we learn best in. So in this chapter, a study was talked about where participants in the study were randomly assigned to 3 types of processing to try to learn and commit some words to memory. A shallow processing, intermediate processing, or deep processing. All groups were given a list of words and they were told to try to learn and remember the words using specific instructions. So those in the shallow processing were given instructions based just on a visual judgment. They were told, here is your list of words that we want you to learn and remember. Look at the list, pay attention to what the words look like, pay attention to how they are printed, whether they are in capitals and bold, whatever. The intermediate processing were given instructions to use rhyming. So they were told, here are the list of words we want you to remember. Go over the list and think of a word that rhymes with the word on the list. And then finally, those in the deep processing condition were given instructions to use semantic judgment. That means here's your list of words to learn. Think about what each of these words mean. Then they tested all groups to see which group actually learned the words best. And as you can see, those that were in the deep processing group, the ones who used the semantic judgment, remembered the most words. All right, so now let's start at that first stage of memory, which is sensory memory. Sensory memory is the briefest form of memory. It is just the residual neural activity from the activation of your senses. So we can talk about memory for all of your senses, but again, as I mentioned with humans, we rely a lot for learning on our eyes and on our ears. So the sensory memory for visual information is sometimes referred to as iconic memory. It is sensory information that is there for less than a second. So after you have seen something, after that visual stimulus has left, for about a second, it's as if you can still picture it in your iconic memory. Our memory for auditory information is referred to as echoic memory. Lasts a little bit longer, sort of the last words in a sentence sort of resonating with you, as if you can still sort of hear what I had just said, even when I have stopped talking. So a famous study done on sensory memory was by a researcher by the name of Sperling. Sperling was convinced that although sensory memory is incredibly brief, that it is the one stage of memory where what you are holding in your memory is an exact replica of what your senses took in. So he designed a study where he showed people an array of letters for 1/20th of a second, sort of as what I'm going to demonstrate now. So look at the screen. I'm going to flash some letters on the screen. See how many of these you can remember. Very brief, huh? Well, in that first stage of the experiment, he asked people how many of the letters they could recall, and at best, they were getting about half of them. However, Sperling was convinced that after those letters have left the screen, they are all still there in your sensory memory as a little photograph, but that because it's there so briefly, by the time he asked you about them, it had already left and been replaced by other visual stimuli. So he came up with a variation to his original experiment. So he flashed letters on the screen, like he did in the original version for 1/20th of a second. But immediately after the letters leaving the screen, he sounded a tone. And he taught his participants that if you hear a high tone, I want you to immediately report back the top line of letters. If you hear a medium tone, I want you to immediately report back the middle line of letters. And if you hear a low tone, I want you to report back the bottom line of letters. When he did the experiment with that variation, people were getting it almost perfectly right. So this demonstrated that everything your eyes took in for a brief second is there. And if I can get you through, for example, using that tone to narrow down where to report back the letters, you can retrieve them. So Sperling's experiment demonstrated that the capacity, how much information can be held in sensory memory, is incredibly huge because it is holding an exact replica of what your senses took in. So just imagine, a quick glance around the room, all the data your eyes are taking in terms of sizes and colors and textures and depth and distance. It's a lot of data, but it's incredibly brief. So what you need to know about sensory memory is that it has a huge capacity because it's taking in an exact replica of what your senses took in, but it's incredibly brief. They're just for a little sliver of time. Now the next stage of memory is short-term memory. Short-term memory has the most limited capacity. It can only hold 7 plus or minus 2 chunks of information. So that means between 5 to 9 bits of information is all it can hold. And it can only hold it for about 30 seconds, most likely less if you get distracted. So you have this graph in your book regarding short-term memory for hearing a series of letters. And you can see that as time increases, the amount of information that you are able to report back decreases because short-term memory you can only keep a limited amount of things in your awareness for a maximum of 30 seconds. There are some interesting facts about short-term memory. Like I said, it's been proven that 7 plus or minus 2 bits of information. For whatever reason, the human short-term memory is better for random digits than for random letters. Our short-term memory is better for what we hear than for what we see. So if I'm trying to tell you a phone number and get you to hold that phone number in your awareness long enough to dial it, you're probably going to have a better time at doing that if I tell you the phone number rather than if I write it down and show it to you. And without rehearsal, without going over that phone number over and over and over until you dial it, you're going to lose it much easier. So with short-term memory having that very limited capacity of 7 plus or minus 2 chunks of information, the more we can group things together and condense things into one chunk, the more we can hold in our immediate awareness. And that is what the next learning objective deals with, chunking. Chunking refers to grouping things together in a meaningful way so that you can fit more into your short-term memory. So if I gave you this random string of letters and said, try to remember as many of them as you can, probably not going to be very successful. But if maybe you could put them into, some chunks and sort of make up silly words and say Uzer, Abum, then you'd probably be able to remember more of them. We are probably more accustomed to chunking when we think of phone numbers. So if you're trying to remember a phone number, we typically remember the area code and we break it down into, the area code, then the first 3 numbers, then the last 4 numbers. And if it's, somewhere that is local, like if you grew up in, the Metro Detroit area, you don't think of 586 as 3 different bits of information. You think of it as one thing, the Macomb County area code. So you're able to better remember that phone number than if you had, the digits that were not chunked. Next chapter, we're going to learn about intelligence and intelligence testing. And one of the tests on a famous intelligence test measures your short-term memory. It's known as the digit span test. And you are simply told strings of digits that get progressively longer and longer. And you are asked to, as soon as I'm done saying them, repeat them back to me. Unless somehow you are able to start chunking, when those digits get to that magic number of 7 digits long, you will see that your ability to repeat back the numbers very quickly falls off. All right, the next concept we're going to talk about is working memory. So short-term memory is simply holding a limited amount of information in your immediate awareness, like that phone number. Working memory is holding something in your awareness and doing something with it. So think of working memory as the processes going on in short-term memory. It is the key to learning. To successfully learn anything, you need to hold little bits of information within your mind at any given amount of time and think about it, process it, try to understand it. So anytime you're holding a little bit of information in your mind and you're doing something with it, you're manipulating it, you are somehow processing it, then that is what is known as working memory. So there's a lot of things that could potentially be going on in working memory. And for those reasons, working memory is sometimes thought of in different functional parts. So we're going to talk about each of those individually. So the first conceptual part of working memory is sometimes referred to as the central executive. It is the part of your working memory that even tells you, hey, this is important, focus on this, pay attention to this. It is the part of your working memory that directs your attention and tells you, what should I do with this information that I'm holding in my awareness? So, like we stated, there is a very finite amount of data you can hold in your immediate awareness at any given time. There are some people who say that they are good at multitasking, that they think they can focus on a lot of things at once. They'll say, well, I can be reading my textbook and talking on the phone and catching what's going on in a TV show all at once. If you think you are a good multitasker, you really are kidding yourself. If you think you are a good multitasker, what you probably have is a very strong central executive that is really good at rapidly shifting attention and swapping out what is in your immediate awareness. But at any given moment in time, there's only so much you can hold in your immediate awareness. And that's the job of the central executive, directing your attention to what you should be focused on right now. The next conceptual component of working memory is referred to as the visual spatial sketchpad. If what you're holding in your immediate awareness and thinking about is a picture, is an image, if you're holding a mental image in your mind, if I say, imagine the route from your current seat to the nearest restroom, then you are using your visual spatial sketchpad. If instead what you're holding in your immediate awareness and processing is something auditory, maybe you're saying something over in your mind, or you have a song stuck in your head or something like that, that is referred to as the phonological loop. And then the final component is known as the episodic buffer. It's sort of this mental workspace where you can bring things together. Sometimes to understand and process what you're holding in your immediate awareness, you might also need to bring to mind a long-term memory. You might need to hold both an image and a thought in your mind at the same time. This is what is known as the episodic buffer, a place where you can bring things together to solve problems, to make a future plan, to assign meaning to things that you have already learned from the past. That is the episodic buffer. All right, so you have this schematic in your book to sort of help you think of those different components of working memory. What is going on in short-term memory? So it's very important everybody knows the roles of the central executive, the visual spatial sketchpad, the phonological loop, and the episodic buffer. All right, the final stage is long-term memory. So from short-term memory, things could either fade away, like maybe you were thinking of that phone number, you dialed that phone number and now you don't need it anymore. Or you could be holding something in your immediate awareness and processing it and telling yourself, this is information I really need to learn, I need to hold on to. And therefore it could be put into long-term memory. So long-term memory is theoretically limitless in capacity. So I'm sorry you can never say, hey, Dr. C, we got to stop right here because I'm all full up. It doesn't happen. And theoretically, it could be a memory that is there for a lifetime. There are different types of long-term memory that we can think about. Some of our long-term memories are things that you can put into words and share with somebody. Those are what are referred to as explicit memories, or sometimes declarative memories. If you can declare it in words, then that's the kind of memory we're talking about here. These include memories like semantic memories, so all of the facts you know, all of the vocabulary, the names, the little bits of knowledge that you know, that would be a semantic memory. And it also includes episodic memories. So these are your life events, the things you have gone through and experienced yourself, from what you had for breakfast this morning to how you celebrated your 5th birthday. That is an episodic memory. Now, some long-term memories, you know they are there, but they're not necessarily the kind of memories that you put into words. These can be memories of things you know how to do, but they're sort of outside of your awareness. They can include things like procedural memories, how to perform actions that you just do without necessarily talking about doing. Those would be an example of an implicit memory. Flashbulb memories are a particular kind of long-term memory. These tend to be memories of significant, often highly emotional events that we remember with incredible detail, without really even trying. They are the kind of memories that we often not only remember the event, but can tell you details about, like, well, where we were when that happened, how that happened. For individuals my age, um, the September 11 attacks in 2001 on the Twin Towers in New York was a flashbulb memory. I can tell you exactly where I was at work and what we were doing and who all was there when we learned about the terrorist attack. I did not consciously say to myself, I need to remember all of this. It just happened. So why is it that flashbulb memories are remembered in such detail? Well, again, to understand it, you have to take your memory back to what you learned about in the chapter on biology and behavior. That we know under stressful situations, your sympathetic nervous system gets activated. It starts preparing all the things that need to happen for you to survive a potential threat and to engage in fight or flight. So you start releasing the stress hormone cortisol. We start producing more glucose, so our body has the energy it needs to survive the potential threat. Well, some of that glucose goes to the brain and it feeds areas of the brain as well, namely the hippocampus and the amygdala. And when those two areas of the brain get stimulated together and get working together, you end up with these very, very vivid, detailed emotional memories. Now, sometimes these memories can result in a symptom of a stress-related disorder, post-traumatic stress disorder, or PTSD. It is the longest studied disorder in psychology. It has been studied going back to World War I, back when it used to be referred to as shell shock, and a very common subject pool for studying PTSD is combat veterans. Combat veterans with PTSD have these flashbulb memories, emotional memories of the trauma that are so vivid, they very easily can come back to the person and haunt them. The littlest triggers can bring back those memories with such vividness that they experience it as if it's going on all over again, and it keeps amping up that stress response. So people with PTSD are in that constant heightened sense of arousal. So let's take it out of, combat vets and think of other potential traumas. Let's consider for this next scenario that the trauma is a young lady was raped. There is an experimental drug known as propranolol that, if it is given shortly after a traumatic event, that it will lessen that heightened stress response and prevent those memories from being encoded with such a vividness, sometimes prevent the memories from being encoded at all. So there's this drug out there that, say a young lady was raped, it might be offered to her in the emergency room. It is experimental, it's not routine, because there are people on both sides of the argument about, is this a good idea or not? There are people who struggle with PTSD who might say, I would have loved for something to have been given to me to prevent this trauma from replaying in my mind every day as it does. Whereas there are others who say, well, if I didn't encode that trauma, it might interfere with my ability to testify if this individual is ever brought to justice. They might say, although it was a terrible thing, it sort of has become part of who I am, part of my identity. It shows that I am resilient, that I have been able to recover from this. So there are people who would be on both sides of the argument about whether that is a good idea or not. All right, so you have this schematic in your chapter as well. Again, a way for you to think of long-term memory. Again, it's important that you're able to differentiate what is an explicit memory and what is an implicit memory, and what are examples of each. All right, so now we're going to talk about how information gets processed, how it gets encoded into long-term memory to begin with. There are some things that get through long-term memory automatically, through automatic processing, unconscious encoding. Those flashbulb memories are just one example of that. Nobody intentionally said, let me try to remember this event. It just sort of got encoded. But a lot of things that are routine, that happen frequently, that are well learned, get into your long-term memory through this automatic processing. So for example, if I asked you, what did you have for breakfast today, and you were able to tell me, that is probably something you processed automatically. It was unconsciously encoded. I doubt anyone was sitting at the breakfast table staring at their cereal box saying, let me remember this in case somebody asks me later. That's an example of automatic processing. Much of what we get into long-term memory, we intentionally want it there. We get it in there through effortful processing. We intentionally focus on it and put effort into learning that information. One of the primary ways we effortfully process memory is through rehearsal, going over and over the information you want to get into your long-term memory. There are different types of rehearsal that we can talk about. Maintenance rehearsal is simply just going over it just the way you know you learned it. That's like holding that phone number and saying it over and over and over in your head just the way it was until you dial the number and you use that information. That's the kind of rehearsal that is good for short-term memory. For long-term memory, we're better off not just going over and over things just the way they were. This is why I am anti-flashcards. If all you're doing is like going over and over vocabulary verbatim, the way it was stated in the textbook, that's not really going to help you learn. To learn, we need elaborative rehearsal. We need more of that deep processing. Not only do you have to go over and over the content, but you have to think about, what does it mean? How do I understand this? How can I relate things that I am learning to stuff I already know? That is more effortful processing. Now let's look at some other things that will improve memory. One thing that has been proven is distributed practice. You are far better off going over your notes every day for just maybe 10 minutes a day than you are spending 3 hours in mass practice the night before an exam. So distributed practice means spreading out your study sessions with breaks in between. Other things that can improve your memory is the use of mnemonics. Mnemonics is a general term for anything that puts something in an easier to remember format for you. So remembering acronyms. So if you grew up in Michigan, hopefully at some elementary social studies teacher taught you that if you remember the word homes, you will remember the Great Lakes, or Roy G. Biv for remembering the order of the colors of the spectrum, or if you ever studied music, remembering the sentence "every good boy deserves fudge" as the sequence of the scales. So all of those are examples of mnemonics using things like acronyms. Another mnemonic that maybe people aren't very familiar with is known as the method of loci. This is a good mnemonic when not only you have to remember something, but you also have to get it in a particular order. So the method of loci involves you first picturing a location that you know very well, like your own home. You know where everything is in your house. You know what you encounter from the time you walk in the front door through walking through your own home. You already know that. You don't have to commit that to memory. So you picture a location like that, and then you take the things that you have to remember in a particular order, and you picture them in different places in your house. So the first thing on your list you might picture at the front door. If once you walk in the front door, the first thing you encounter maybe is a coat closet, then the next thing on the list you would picture in the closet. If you walk further into your house and say you encounter the kitchen, then you would imagine the next thing on your list sitting on the kitchen counter. If you keep walking into your house and it goes into your living room, then you might picture the next thing on the list on your sofa. And then when you want to retrieve those items and get them in the right order, you just sort of take a mental walk in your mind and pick up the items in the different locations that you've imagined them in. That is known as the method of loci. Using the method of loci involves visualization, and you can use visual encoding as a memory strategy. So try to use visual encoding to remember these words. Now, likely some of the words you found it easier to remember them through visual encoding because they were words that you could picture. You could picture a pencil, you could picture a piano, a cigar, but what kind of picture do you conjure up for a word like vague or inherent? So when it comes to mnemonics, there's no right or wrong. It's what is going to help you best, what's going to work for you. So if you can associate a picture with what you're trying to remember, that will help. Other things that help your memory are organization. The more organized the information is you are trying to encode, the better you're going to be able to learn it and remember it. So if you can put the information you are trying to learn in a hierarchical structure, it's going to be easier for you to learn and remember that information. So as an example, let's say I wanted you to remember all of these specific species of animals. And if I gave them to you all randomly mixed up, you would probably have a hard time committing them to memory. But if you could put them into a hierarchy and see, okay, some of these animals are birds, some of them are mammals. Some of the birds are ones that live in the water. Some of them are songbirds. And you start organizing them in that way, you'd probably be able to remember much more of those species of animals. So when you're trying to think of organization related to stuff you're learning, even in this course, if you have a good textbook like we do for this course, a lot of that organization and hierarchical structure is already there for you. You just have to recognize it and pay attention to it. So how is the chapter broken up? What are the section headers and then the subsection headers? Those are things that if you pay attention to the organization, it will help you learn that content better. We talked about this one in our consciousness chapter. One very simple thing that helps memory is sleep. We do know from that chapter that your hippocampus is active during stage 2. We know that another reason sleep might help is because if you go to sleep immediately after studying something, then you're not letting any other interfering information get into your mind that could potentially confuse you. So that's another reason why sleep might help. Another way we can improve our memory is to make use of retrieval cues. Retrieval cues are little things that will jar your memory, things that should help you retrieve information that you have stored. So you might have had a class where you took in-class exams, and you might have had an instructor say, you can bring in 1 page of notes as a memory aid for you during the exam. If the exam is on 5 chapters or something, you can't possibly fit 5 chapters worth of content on that 1 page, but you definitely can fit some retrieval cues, some things that should spark your memory if you struggle with thinking of something during the exam. So it's as if, you can't remember somebody's name and then someone gives you the first letter of their name. Then you're better able to do it. That's a retrieval cue. So if, for example, I said, do you remember the name of this animated cartoon character? And if you didn't, and then I gave you the retrieval cues, gave you the first letters, then even if you struggled with remembering it at first, you probably would be able to get who framed Roger Rabbit. That is the name of the movie that this character is from. Priming is a term for how retrieval cues might activate certain memories. So in the video you watched at the beginning of this chapter, you saw memory researcher Elizabeth Loftus use the example of, I've got a 6-letter word, and the first 3 letters are H-A-M, and I want you to guess what the word is. And she used the example that if we did that, just like that, many people would say, maybe it's the word hammer. But if earlier in the day someone was talking about Shakespeare, you might not be consciously thinking of Shakespeare, but because Shakespeare primed certain concepts in your head, you might then come up with the word Hamlet. That's an example of priming, activation of an existing memory by a stimulus, often unconsciously. So if I said, for example, spell the word hair, chances are, because on the previous slide you saw a picture of Roger Rabbit, there'd be more people than normal spelling the word hair, H-A-R-E, as in hare the rabbit, than H-A-I-R, as in hair on your head. Other things that impact our memory is simply the order. This is what is known as the serial position effect. When we are trying to remember things in a list, we tend to remember things at the beginning of the list and at the end of the list the best. And if we're going to screw something up, we will screw something up in the middle. To sort of demonstrate this for yourself, without singing it, try to think of the words of the national anthem. If you struggle with that, chances are it's not the beginning. Almost everyone gets, "Oh, say, can you see?" And chances are it's nothing at the end. You're not going to lose, the home of the brave. If you screw up, it's going to be somewhere in the middle. Now, this is the actual full song of the national anthem. Did you know there were this many verses? Thank goodness that we don't have to listen to the whole thing, before the game starts. We would get really bored. Or think of, a few years back when, oh God, Fergie did that absolutely awful version. If we had to listen to all the verses, how awful that would be. But even when people are singing the national anthem and we've got these big name stars doing it, they screw up too. And almost nobody screws up the beginning. They'll screw up somewhere in the middle. And by the time they get to the end, they somehow remember, or the land of the free and the home of the brave. That is because of the serial position effect. You have a little active psych demonstration here that you can access through that link if you want to learn more about the serial position effect. So why does this happen? Well, remembering things at the end of the list best is referred to as the recency effect. One of the reasons why we might remember things better at the end is because maybe those things are still in our short-term memory. Maybe we have been rehearsing them to ourselves, and those things at the end were still within our short-term memory, and we're able to retrieve them better. Now, when there's a long delay, you're going to remember things best at the beginning. That is known as the primacy effect. So let's say that you've learned a list of words today, and then it's not until 2 days later that I ask you to try to remember that list. Chances are you're going to remember things that were at the beginning of that list better because of the primacy effect. It's been a long delay, so your short-term memory can't be helping you. It could simply be those words on the beginning of the list I've had more time to work with, and I've had more time to study them. So that's known as the primacy and the recency effect.